As we finish the rest of Chapter 2, we're going to focus a little bit more on the subtraction, and we're going to continue with this kind of lining up policy that we've kind of begun here. So, start by writing my first number, lining my stuff up right in the decimal, and then the second number, so if I'm going to subtract this, first thing I have to check is whether they have the same number of decimal places, and they do. These both have 4 digits of decimals, or numbers that are in the decimal places. So my job really is going to be to start with this column and subtract. So 7 minus 3 is 4. 5 minus 1 is 4. But in these next two columns, we're going to have to really deal with some borrowing. So we're going to have to go over here and borrow, make this a 2, make that a 10, which does well for here, but still creates a problem here. So I have to borrow one more time. This is going to become a 9, and that's going to become a 10. So 10 minus 4 is 6. 9 minus 4 is 5. The good thing about this lining up method is I have no doubt where that decimal is going to go. But I can't take 8 away from 2, so I have to borrow one more time. So 12 minus 8 is 4. Now, on a problem like this, when I end up with this answer, remember, taking our numbers and adding them back together, especially when you borrow, you want to make sure that you end up with the number that you started with, or you'll know you've done something wrong. Okay, now this number happens to match this, so that means that you did the right thing. Okay, remember, we have to be careful on some of those to make sure if we need to back up and figure out what we did wrong, we can. Okay, next one. Okay, multiplying. Normally when we set these up, we're going to set these up like a multiplication problem like we do anything else, except the thing with the least amount of digits is going to go second. Now just tell you, in this number right here, this 0 that's in front of that decimal is not considered a significant value. So when I write that down, I'm actually going to write it down like this. Same thing with this one. This one is not considered a significant value, so I'm going to do this. Now remember, in this one you set it up just like a regular multiplication problem, and in fact we're going to multiply and we are going to pretend that there's no decimal even there. So if I do that, 8 times 1 is 8. 8 times 4 is 64, so 4, carry your 6. 8 times 0 is 0, plus 6 is 6, and then 8 times 0 is 0. Now, the one thing that we have to consider once we get done is how many numbers are actually in decimal places. So if I count it up, there'd be 1, 2, 3, 4 in this number, and 5. So there has to be 5 total decimal places when you get done in your answer. So if I were to look at this, 1, 2, 3, 4, to get 5 it would be here. So that leaves us imagining what would have to be here. We're going to add a 0 here. So that means my answer is going to be 0.00648. Now remember, don't deal with these total decimal pieces until you're at the very end of your problem. Okay, let's go to the next one. Okay, and this one, just like on the last one, if we look at the multiplying problem, these are not those significant values. So if we write this out, because these are really the same length as far as decimal places, we're just kind of stacking one on top of the other. And I'm going to go through and multiply this out and pretend like the decimals aren't there. We will deal with the decimals at the end. So if we do that, 4 times 6 is 24, so 4, carry your 2. 4 times 4 is 16, plus that 2 would be 18, so 8, carry your 1. 4 times 0 is 0, plus 1 would be 1. So 184 there. Now when I go to this one, I'm going to have to add a 0, my placeholder. Then 1 times 6 is 6. 1 times 4 is 4. 1 times 0 is 0. And then I'm going to total my stuff. So here's my values. Now I do know back up in this problem, if I were to count 1, 2, 3, 4, 5, 6. So 6 decimal places. So in my answer I have to have 6 decimal places. So 1, 2, 3, 4, 5, 6. So I'd have to add 2 decimal places. So 0.0000644 is going to be your final answer. Okay, let's go to division. In my dividing, a lot of these, if they're not going to come out evenly, you'll see round to the nearest tenth. So listen, when I go to set up this problem, it's still, remember that inside out part. So 4 is on the outside, and 96/36 is underneath. Now they're telling me to round to the nearest tenth, which means that I'm going to have to divide out to the hundredth to decide if I need to round or not. So if I do, I'm just going to go through and create that screen kind of like I did before, one piece at a time. So 4 would go into 9 twice. That would be 8, and there would be 1 left over. Bring down the next value. 4 would go into 16 4 times, which leaves me with 0. Then I'm going to bring my 3 down. Before I do though, I'm going to make sure my decimals proud and loud there in the middle of my answer. So 4 does not go into 3, so there's to be a 0 that goes there. Four we're going to 36 9 times with nothing left over. Now see, the issue is a lot of people would get done and think, oh, it came out evenly. My answer is 24.09. But remember, if this is the answer that you get, they've asked us in this one to round here. So we have to look at this number, and it's 5 or greater, so that means that's going to round this 0 up to a 1. So this is really going to be my answer. And that's going to trip several of you up this week, so please make sure that you watch that part. Okay, let's try one more divide. Now, so far we haven't had to do any moving of the decimal places when we've talked about divide. Here's where the problem is different. You have to move the decimal when the number that's in front of the division bar is a non-whole number. So let's set this one up. I'll show you what I mean. So inside out. So here's my inside. 0.89 is outside. Now the big thing with this problem is this is the number that has to be a whole number. And right now it's 0.89. I'd actually have to move this 2 places to make it a whole number. And whatever I do to this, I have to do to this. So now this becomes 89 divided into 4,055.50. Now I tend to rewrite it every time because I think it's easier, but your decimal then will be in the right spot for your answer. Okay, now if I were to go and look at this problem now, I'm going to put that screen up, and we'll do kind of what we were doing before. 89 does not go into 4. 89 does not go into 40. 89 into 405. I'm thinking 4 times. Let's see. Well, that's as close as I'm going to get without going over. So there's my 4. Goes in here 356 times. Let's see. So 49 left over, which is less than 89, so good so far. Bring down my 5. So how many times does 89 go into 495? And I'm thinking 5. Okay, so 5 times, as close as I can get without going over. 50 left over. 50 is less than 89, so good so far. Bring my 5 down. And I have this one other 0 that's left here, so I'm just trying to keep my eye on the ball here. So I want to figure out how many times it goes into 505. Let's see. If I went times 6, four, carry your 5. Okay, that's too big, so we're back down to this again. So it goes in there 5 times. 445. So 60. 600. Goes in there 6 times. This is less than that. So I know even if this were to go on further, I'm going to stop at this point because I have to run to the nearest 100th. Okay, so if I'm rounding to the nearest 10th, excuse me. So I had to go the 100th, so that means this spot's where I'm rounding to, and this is enough to make it round up. So 45.6 is going to be my final answer. Okay, let's see if we can squeeze in one of these order of operations. So please excuse my dear Aunt Sally. So in this one, parentheses get used a little bit more in this section, mainly because they want to make sure that you know that the exponent is with this decimal in particular. So this one right here is my exponent. There's no real parentheses, so I'm going to do exponents. So this is really 0.8 times 0.8. So our shortcut method would be 8 times 8 is 64 and 2 decimal places. So it'll be 0.64. So I'm going to bring down what's in front of it, and I'm going to bring down what's behind it. And exponents are done. No multiplying and dividing, simply adding. So really, if I make a big line here, I should be able to solve this whole problem right there. So 4.1 and 0.64, adding. Let's see, add a 0 here. So if I go through and total this, 4, 7, 4, there's the first part. And then I'm just going to add my subtracting the 14 cents basically underneath this. So on this one, 4.60, or some people may write this as 4.6, is going to be your final answer.